This video will be about graphing quadratics. When you're graphing a quadratic, the standard form of a quadratic is y equals ax squared plus bx plus c. What makes this a quadratic is really the x squared piece. That's what you have to have for something to be a quadratic. You could be missing the bx piece, you could be missing the c piece. As long as it has that ax squared piece, then you have a quadratic function. The graph of a quadratic, that's a really bad line, I'm going to read it out. The graph of a quadratic is always in a U shape. We call this shape a parabola. Now this can move around, it doesn't have to be just there. It could go to the right, it could go to the left or down, or it could flip completely upside down. It could be skinnier. These are all quadratics. When we graph a quadratic, the most important point to find first is the vertex of the quadratic. That's either the top point or the bottom point, depending on if you're facing up or facing down. And a vertex is just a point, so it has an x-coordinate and a y-coordinate that we have to find. The x-coordinate we have to find using a formula. So for the x-coordinate, you use the formula x equals negative b over 2a. So you're going to have to replace the letter b, and you're going to have to replace the letter a in order to use this formula. So let's say we had y equals 2x squared minus 4x plus 10, and we wanted to find the vertex. So first we'd find the x-coordinate. We'll talk about how to find the y-coordinate after we find the x-coordinate. To find the x-coordinate, we have to figure out which of these numbers is a, which one's b, which one's c. Well, a is always the number in front of x squared. So just the number 2 is a. B is always the number in front of x. So the negative 4 is b. We're going to take those and we're going to plug them into the formula. Sorry, I moved where it was recording. So the formula was negative b over 2a. We still have the negative sign from the formula. Then we have negative 4, so we actually have a double negative sign. Usually we put it in parentheses just so it doesn't look really weird. Over 2 times a. Again, I'm going to put this in parentheses, so 2 times 2. Now we simplify this down. A negative by a negative is a positive 4. 2 times 2 is 4. And we can divide this. 4 divided by 4 is 1. So that is the x-coordinate of our vertex. When you're looking at the picture, the parabola also has an axis of symmetry. That's a line that goes through the middle. This x-coordinate would also tell us our axis of symmetry. They actually go through the same number. So the x-coordinate is 1. Still have to look for the y-coordinate. The axis of symmetry would be x equals 1. That's the line where we could cut the parabola in half at. Now to find the y-coordinate, we're going to take that x-coordinate and plug it back into the original equation. So our original equation was the y equals 2x squared minus 4x plus 10. We're going to plug that 1 in everywhere we see the letter x. So we have 2 times 1 squared. I replaced the letter x with a 1. Minus 4 times 1 plus 10. And now we simplify this. 1 squared is 1. So we'll have 2 times 1 minus 4 times 1 plus 10. We do our multiplication next. 2 times 1 is 2. 4 times 1 is 4 plus 10. And then going left to right, we subtract and add. 2 minus 4 is negative 2. We still have our plus 10. Negative 2 plus 10 is positive 8. So now we have our entire vertex. We have our x-coordinate of 1, our y-coordinate of 8, so it would be 1, 8. Our axis of symmetry still is that x equals 1. So our graph would look something like this. Hopefully I counted 8 up correctly. And there would be our quadratic function. Now, they also talked about quadratic inequalities. You're going to graph an inequality the same way that you graphed this quadratic. So let's actually take that same function, because we already have the vertex. It is y equals 2x squared minus 4x plus 10. But what they're going to change about an inequality is instead of having an equal sign, they're going to say less than, or could say greater than, or less than or equal to, or greater than or equal to. And this less than sign tells us to do some things. So there's two things that our inequalities do. They are either solid or dotted. So you're either going to draw just a regular parabola, or it's going to be kind of dashed, I guess would be the better word than dotted. Or you're going to shade inside or shade outside. If you shade inside, it would be kind of in the middle of the parabola. If you shade outside, it would be like this. And you try and fill up the whole outside area. So the way we know which one, and we actually have to choose, we're either going to be solid or dotted and shade inside or outside. So I could be solid and shade inside, or I could be solid and shade outside. I could be dotted and shade inside, dotted and shade outside. It depends on the symbol that they give you. So we have a solid line when we have less than or equal to, or greater than or equal to. The equal to means we're using the parabola itself and not just the shaded part. The dotted line happens when we have the symbol less than or greater than. Shading inside or shading outside is a different combination of symbols. Shading inside you do when you have, well, I guess it depends if your parabola is up or down. So if your parabola is facing up, you shade inside when it's greater than or equal to. You shade outside when it's less than or equal to. But that can change if your parabola flips. If your parabola is upside down, you actually shade inside when it's less than or equal to. Less than is below the line. Or outside, when your parabola is upside down, would be greater than or equal to. So there's a lot of combinations. We look at our symbol, less than. So looking whether it's solid or dotted, that means it would be a dotted line. Then we look for shading inside or outside. Now we know our parabola is facing up or down depending on this first number. Since the 2 in the very front by the x squared is positive, we're facing up. If that number by the x squared is negative, we're facing down. So we're facing up and we have a less than symbol. That means it's going to be outside the shape. So we already know the vertex because we calculated it before. The vertex was at 1, 8. And we know we're facing up. So we said that this would be a dashed line. Sorry, I'm running into the equation. And we said it would be shading inside, nope, shading outside the shape. And really we could fill up the whole graph, but it'll only color in so much on this. So let's try one more. Say we have y greater than or equal to negative x squared plus 8x. So this is what we're starting with. We still need to know our a and our b to find our vertex to start our graph. A is the number in front of x squared. Right now, though, there's nothing written there. We have to assume it's the invisible -1. So -1 is A, 8 is B. We go plug that into the formula, negative B over 2A. So negative 8, 8 was positive this time, so we don't need that extra negative sign that we had last time. Over 2 times A is -1. Then we simplify, negative 8 over -2 equals +4. So that would be the x-coordinate of our vertex and the axis of symmetry. It's actually 2 things. Then we have to go and find our y-coordinate. We still replace, even though this is an inequality, we still replace every x value with a 4, with the number we got for our x value. So now we simplify. We square first. -4 squared is 16. Then we multiply. -1 times 16 is -16. 8 times 4 is 32. -16 plus 32 is +16. So our vertex is 4, 16. We also know that since the very first number in front of x squared was negative, that we're going to be facing down instead of up this time. Okay, so 16 will be all the way up here, and we're facing down. Now before we go and draw our graph, we need to decide whether it's going to be solid lines or dotted lines. Looking at our symbol greater than or equal to, the difference between solid and dotted was whether there was a line underneath. There is a line underneath the inequality symbol, which means we have solid. And we could keep the arrows going down until we hit the very bottom of the graph. I shouldn't be quite so lazy with my drawing. So now we have to decide where we shade. Greater than, when we're facing down will mean we shade on the outside. Another way to think about the shading is above and below. Greater than would be above, and this way it doesn't matter if we're facing up or down. Greater than would always be above, less than would always be below. So greater than means above our picture. So the last thing I saw that they might ask you to do is to find the equation based off of the picture. Let's say we have a graph. It looks like this. And we want to know which equation. So this one I'm going to give some multiple choice answers. So we have to decide which one of these is the correct answer. So we kind of have two options. We can either go through each answer and find the vertex to see if it matches the picture, or we can take the vertex and see if plugging in the x-coordinate gives us the same y-coordinate. I think the second option is easier. So looking at our graph, we went right 3 and up 9. So we have a coordinate of 3, 9. I'm going to go plug this into each equation and see which one gives me the same answer of a 9. So instead of writing x here, I'm going to replace it with 3. We square first. 3 squared is 9. The negative out front will still be there though. Negative 9 plus 6 is negative 3. That one did not work. We're trying to get a positive 9 as our y-coordinate. So now we go and do it again. Negative 3 squared plus 6 times 3. 3 squared again is 9. We still get that negative 9 plus 6 times 3 is 18. Negative 9 plus 18 is positive 9. Luckily for us, the second one was our answer, so we didn't have to do it a third time. So those ones you kind of have to use the multiple choice answers to help you figure out which picture is correct.